Humbert here, and today we're going to be doing Unit 8, Note 7, so we're going to be talking about the distance formula and how to apply the distance formula. So let's kind of take a look at how we're going to be applying this. So a certain helicopter can fly 450 miles before it needs to refuel. So now we're trying to fly from Minneapolis to Chicago. Now, Chicago is 225 miles east. So 225 miles east, and then it is 175 miles south. So we want to figure out if they can make it one way without refueling. Well, are we going to go all the way east and all the way south? No, we're going to fly along the hypotenuse. So what I'm going to do to start off with is I'm going to use the Pythagorean theorem to figure this out. Okay, so I'm going to do 225 squared plus 175 squared and see if that's equal to x squared. So 225 squared is going to be 50,625, and then 175 squared is going to give me 30,625, and that's going to be equal to x squared. So then I add those two together. And when I add them together, I end up getting 81,250. So in order to solve for x, I'm going to need to take the square root of both sides. So I get x is equal to the square root of 81,250. Now for the majority of this unit, we've been trying to simplify the radicals down into pairs. Well, what I want to know is I want to know if this radical is less than 450 miles. So I'm actually going to take the square root. And when I take the square root, I get 285.04 miles. So that's approximately, now it's approximate because we didn't write it as a simplified radical. So that's approximately how many miles it is to Chicago. Is that less than 450 miles? Yes, it is. So yes, our helicopter can make it all the way there without needing to refuel. So let's go ahead and let's take a look at the distance formula. The distance formula is used to calculate the distance between 2 points. So we typically label those points as x1, y1 and x2, y2. So basically here's our formula. It's the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So then what we're going to do is we are going to go ahead and apply these to 2 points. Okay? All right, so let's go ahead and let's take a look now. So taking a look at number 1, I like to start by actually labeling my points so then I don't lose track of them. So this one, x1, y1, x2, y2. So that just kind of helps me keep track of it. So now I'm going to put it into the formula. So what I have is the square root of x2 minus x1 plus y2 minus y1. Now recall that whenever you subtract a negative, it's going to become plus a positive. So then we have the square root of 11 minus 5, which is going to give me 6 and then squared. And then 7 plus 1 is going to give me 8 and then squared. So then I end up getting the square root of 64 plus 36. You add those two together and you get the square root of 100. Well, if you know your perfect squares, that's going to make this note sheet a lot easier because we know that the square root of 100 is 10. So the final answer for number 1 is 10. So let's go ahead and let's take a look at number 2. So again, we're going to label our points x1, y1, x2, y2. And then we're going to go ahead and take our square root. So we're going to do the square root of x1 minus, or x2, sorry, minus x1. So that's going to become plus a positive when you subtract a negative, plus 17 minus 2, because that's y2 minus y1. So then we get the square root. 4 plus 4 is 8, so we get 8 squared plus 15 squared. So then we get the square root of 64 plus 225, and that's all underneath the radical, which ends up being the square root of 289. Again, knowing your perfect squares helps here because the square root of 289 is 17. So here our answer is just 17. So let's go ahead and let's take a look at number 3. So we have x1, y1, x2, y2. So then I have the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So now when we take a look at this, so we have negative 4 minus 2, so that's going to get more negative and give us negative 6 squared. Okay? So then we want to do 6 minus 3, which is 3 squared. So then, now we need to figure this out. So first of all, I want you guys to remember that when you square a negative 6, it's going to become positive. And you can make sure your calculator does that correctly by putting it in parentheses. So we get 36 plus 3 squared, which is 9. So then I end up getting the square root. Did I do that right? Oh, yeah, okay. So then we end up getting the square root of 45. So now we want to break that into 45, or into our pairs. So 45 divides into 9 and 5, and 9 we can break down to 3 and 3. So I can take out a pair of 3's. So I'm going to take out a pair of 3's, and left underneath the radical is 5. So 3 square root of 5 is our final answer for number 3. So let's now take a look at number 4. So for number 4, we're going to label our points x1, y1, x2, y2. And now we're going to go ahead and we're going to take the square root. So we're going to do x2 minus x1, quantity squared. Oops, x1 is 4, Miss Humbert. Plus y2 minus y1. When you subtract off that negative 1, it's going to become plus a positive. So negative 2 minus 4 is negative 6, and then squared. Negative 5 plus 1 is going to give me negative 4, and then squared. So then what I end up getting is the square root of 36 plus 16, which gives me the square root of 52. So now I need to work into breaking this down into radicals. 52 divided by 4 is 13. So then I can break the 4 down to 2 and 2. So I can take out a pair of 2's. And once I've taken out a pair of 2's, I have 13 left underneath the radical. So 2 square root of 13 is our final answer for number 4. Let's take a look at number 5. It says Tracy's golf ball was hit 20 feet short and 8 feet to the right of the cup. So I am going to call my golf hole itself the origin. It's at 0, 0. So we're 20 feet short. And whenever we go down, that's going to be a negative. And then we're 8 feet to the right, and that's positive. Now, if you're looking at a graph, remember that you want to do positive, or you want to do your horizontal distance first, and then your vertical distance. So here's my x1 and my y1. And then we want to do, then when she hits it, it lands 2 feet to the left. Now left is negative, and up is positive. So we want to do how many we went over and how many we went up. And this will be our x2 and our y2. So now we want to plug it into the distance formula. So what I have here is x2 minus x1, quantity squared, plus y2 minus y1. So that's going to become plus a positive when we subtract that out. So negative 2 minus 8, that's going to give me a negative 10, and that's squared. 3 plus 20 is going to give me 23, and again, that is squared as well. So when you square a negative number, it becomes positive. Negative 10 squared is 100. 23 squared is going to give us 529. So then what we get is the square root of 629. So then I took the square root and I took 629 and I tried dividing it by 3, by 7, by 11. I tried dividing it by basically any prime number I could think of. And I didn't end up finding any pairs at all. So this right here is your simplified radical because there are no pairs. The last thing we need to do is label it. So that is how many feet it went in total. Let's go ahead and let's take a look at number 6 now. So for number 6, she's on her way to college campus. She has her first class in Rhodes Hall. So what I'm going to do is I'm going to call Rhodes Hall 0, 0. And that's going to be my x1 and my y1. And then she's going 1/4 of a mile this way, 3/8 of a mile this way, so that's going to be negative, and 1/8 of a mile this way. So I need to figure out how much total she goes over. Well, 1/4 is really the same as 2/8 if you multiply both by 2. 2/8 plus 1/8 is 3/8. So she ends up going a total of 3/8 miles to the right. So she goes a total of 3/8 miles to the right, and then she goes 3/8 miles down. So that's my x2 and my y2. And now I need to plug that into the distance formula. So I'm going to do x2 minus x1 and square it plus y2 minus y1, and that's negative, and square it. So then I end up getting 3/8 squared plus negative 3/8 and squared. So now when I square it, I need to square the top and the bottom. So 3 squared is 9. 8 squared is 64. Same for this one. Negative 3 squared is still 9 over 64. Now when you're adding fractions, you can add them if the top or if the bottom is the same. So what I end up getting is 18 over 64. So I'm going to split that up into two different radicals, just like we did when we were rationalizing the denominator. Well, thankfully, the square root of 64 is just 8. So I can write 8 on the bottom, and then I just have the square root of 18 left on top. So I need to break down the square root of 18. Well, 18 breaks into 9 and 2, and then 3 and 3. So I can go ahead and I can take out a pair of 3's. Left underneath the radical is 2, and that's divided by 8. Well, the fraction 3 over 8 is on the outside, and that can't be divided anymore. So that is fully simplified. So the final answer is 3 square root of 2 divided by 8 miles. So where does this distance formula come from? Well, let's set it up. So let's do the point 0, 4. Or sorry, that'd be 4, 0. And then I want to figure out the distance to 5, 0. Okay? So then we're going to go ahead and I want us to use first the distance formula, and this should be 0, 5, number, because your x coordinate. So first let's use the Pythagorean theorem, okay? Or sorry, not the Pythagorean theorem, the distance formula. So let's calculate out the distance. So we have, oh, that doesn't show up well at all, does it? Okay. So we have x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So what I end up getting is the square root of 4 squared plus negative 5 squared. So that's going to be the square root of 16 plus 25, which gives me the square root of 41. And that cannot be simplified. Okay? Now, if you take a look at this triangle that we have here, this has a distance of 4, and this has a distance of 5. So let's try it using the Pythagorean theorem. So we're going to have 4 squared plus 5 squared is equal to x squared. So 16 plus 25 is equal to x squared. So x is equal to the square root of 41. When you add 16 plus 25, you get 41. Take the square root of both sides, and you end up getting the square root of 41. So both of those are really the same thing. The distance formula does the exact same thing as the Pythagorean theorem, but with coordinate points. So let's take a look at some more in-depth problems here. So find the possible values of A if the distance between the 2 points is 10 units. So we're going to do x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now that's going to be equal to 10. So what I end up getting here is the square root of a minus 7 squared plus negative 10 squared is equal to 10. So then I get the square root of a minus 7 quantity squared plus 100 is equal to 10. So then what I need to do now is I need to start solving this radical equation. So the first thing I need to do is get rid of the square root. Since it's isolated, I'm going to go ahead and square both sides. So then I get a minus 7 quantity squared plus 100 Oh, this should be minus 5. I apologize. That's where my mistake was. And this should be 8 and 64. Well, I figured it out. Goodness gracious, Miss Humbert. So I apologize. Let's fix this here. So this should be a minus 7 quantity squared plus 64 now is equal to 10 squared, which is 100. So now I need to solve for a minus 7 squared. So I'm going to subtract 64 from both sides, and then I get a minus 7 quantity squared is equal to 36. So now, in order to solve for a, I need to get rid of that square. So I'm going to undo it by taking the square root of both sides. So I get a minus 7 is equal to 6 when you take the square root of 36, and then you get 7. So then you get A is equal to 6 plus 7, which is going to give you, goodness gracious, 13. So let's try one where I don't have as much of a struggle bus, shall we? So let's go ahead and let's set this up. So what I have is I have x2 minus x1 plus y2 minus y1, and that's equal to the square root of 58. So then what I end up getting is negative 7 squared plus 5 minus a quantity squared, and that's equal to the square root of 58. So now I have those radicals completely isolated, so I'm going to go ahead and square both sides. So I get negative 7 squared, which is 49. That radical is going to go away. So I have 49 plus 5 minus a quantity squared is equal to 58. Now it's equal to 58 because when you take the square of the square root, you just get that number. And then I'm going to subtract 49 from both sides, and I get 5 minus a quantity squared is equal to 9. So now in order to access that a, I need to take the square root of both sides. So I get 5 minus a is equal to 3. Then I'm going to subtract 5 from both sides, and I get that a negative a is equal to a negative 2. Divide both sides by a negative 1, and I get that a is equal to 2. So that is our final answer. I apologize about that struggle bus, so go ahead and take your Schoology quiz once you're done. Thanks for listening.